Kia ora koutou katoa, it's Mrs. Goodson here, and this is a video about rates of reaction. And it is about how to write a method for a chemical investigation. So it follows on from the earlier videos about the theory of rate of reaction and the how to design an investigation. So the method is a step-by-step instructions on how to carry out the experiment. So you want to number your steps. The first thing is it must include what you're going to change, the independent variable, how you're going to change it, and it must have a suitable range. So you need at least, we're going to aim for 4 different times spread out, and make sure you include the units. So for concentration, that would be percentage. For time, that would be seconds. For surface area, we're just going to describe it. So dependent variable, how are we going to measure it? So we're going to be measuring time. We're going to use a stopwatch. We're going to do it in seconds. We're going to make sure the same person does it so that the measurements are reliable. And we're going to use a stopwatch, as I said, that's the equipment. Control variables. This is really important that you include this in your method. The things that might affect the results that you're going to keep the same. As many as possible, but you want to have at least try and aim for 3 or 4 things in your method that you're going to keep the same. Think about how they can affect your experiment, and in your discussion, that's the written report part, but later on, you'll talk about how controlling these affects the accuracy and validity and reliability of your experiment. So just in your method, just don't need to explain them in your method, you just need to describe how you're going to do it. And for chemistry, we're not going to worry too much about sampling bias or sources of error. And you need to make sure you include your repeats in your method at least 3 times for each independent variable value. This is a bit of an example method. You can adjust it, make it better, make it yours. Collect the equipment. So we want a 250ml conical flask, a card with an X on it, a stopwatch, a 5ml measuring cylinder, and a 50ml measuring cylinder. You want to measure out 50 ml of 100% solution A, 5 ml of solution B with a measuring cylinder. Check the volume at eye level. This is one of our controls here. Check the volume at eye level and take the reading from the bottom of the meniscus. Put the conical flask on the X card, add solution A and B to the flask, and start the timer. Stop the timer when the X cannot be seen. Have the same person decide. That's another control there. Clean out the flask. That's an important control so that the starting point is always the same. We've got a nice clean flask. Then we've got our repeats for reliability. Oh, this one here is the different values for the independent variable, so that gives us our range. And then this one here, repeat steps 2 to 5 2 more times. So you can say you do it 3 times or repeat twice more, whatever wording you like, but make sure that you include the repeats because that's how we're going to make it reliable. What makes a good method? You want step-by-step numbered, step-by-step instructions. Nice and simple. You want it easy to understand. Lots of detail, what equipment to use, what volumes and concentrations of solutions to use. You want the repeats included. Actually, that's something that is not in this method. Oh yeah, we've got the concentration of this, but we don't have the concentration of solution B. But we maybe want to say that we use the same, when we do our repeats, we're going to use the same stock of solution B, so it's always the same concentration. So think about the things we want to keep the same. We want to include that in our method. We want to include how to change the independent variable, how to measure the dependent variable, and how to control the controlled variables. So this video has been about writing a method so that the independent variable, the dependent variable, and the things that get the same are in your method.